Okay, these are the trig problems from lesson 54. So we're going to solve cosine theta equals negative square root of 2 over 2. So to do that, what we have to do is we have to find out where cosine is negative square root of 2 over 2. So we look at the unit circle, and we try to find out when x is negative square root of 2 over 2. We know it's going to be over here. This is where x is negative. So we're looking at here at the 45 degree and down here at this 45 degree angle. So this is going to be, this is 135, and then over here in the third quadrant it's 225. So we've got 135 and 225 for our possibilities. So theta is either 135 or 225. And those are the only possibilities between 0 and 360, and this is not supposed to be less than or equal to. Okay, sine 3 theta minus 1/2 is 0. First thing we do is isolate the trig function, so add 1/2 on both sides. Sine 3 theta equals 1/2, and now we're looking for where sine is 1/2. And you should be pretty familiar with that. You should know that it's 30 and 150. If you look at your unit circle, it's right here at 30 degrees, that's where sine is 1/2, and 150 over here in the second quadrant, sine is also 1/2. So sorry about that. Okay, so 3 theta has to be either 30 or 3 theta is 150. So to get theta by itself, you divide by 3, so theta is 10. Or theta is 50. Now again, we have this argument that is multiplied by 3, so since theta can be between 0 and 360, that means that 3 theta can be between 0 and 3 times 360. So I can keep spinning around the circle, and instead of adding 360 to this and then dividing by 3 to get theta, I can just go ahead and divide 360 by 3 and get 120, and just add 120 to theta itself until I get out of range. So if I add 120 to 10, I get 130, and I can add another 120, and that'll put me at 250. If I add another 120, that's going to put me at 370. That's too big, so don't do that. Alright, and then for 50, I can also add 120 until I get out of range. So 50 plus 120 is 170, and then add another 120, and that puts you at 290. Okay, so all these values are going to work in this equation because I can have theta going all the way up to 360, and any of these values I put in for 3 theta will just spin me around the circle back to 30 and 150 again, those same two places in the first and second quadrants where we have a 30 degree angle. So you've got 6 answers here, and when you have a coefficient on your theta that is greater than 1, you're going to have more than just 2 answers most of the time. Alright, secant 2 theta minus 1 is 0, so we want to, again, isolate the trig function, add 1 on both sides, so we would get secant 2 theta equals 1. Alright, so secant, remember, is 1 over cosine, so we're going to look at cosine on our unit circle and see when cosine is 1. And you should know that cosine is 1 at 0 degrees. That's where that happens. I'm not even going to flip over to the unit circle. Cosine is 1 when x is 1, and that is at the point 1, 0, which is on the x-axis on the right, and that is 0 degrees. So if secant 2 theta is 1, then 2 theta must be 1 over 1, which is just 1. So therefore, 2 theta is 0 degrees, which is when cosine is 1. So theta would have to be 0. If you divide both sides by 2, you still get 0 degrees. But since we have an argument where we have a coefficient greater than 1, we can just divide 360 by 2 and see if we can add some things to theta to get more values, to get more answers. So if we divide 2 into 360, we get 180. That tells me that I can add 180 to this, and I'll get 180 for another value of theta. And if I'm not sure if that works, I'll just stick it back into the equation, because if I stick it back in here, secant 2 theta, if theta is 180, that's going to be secant 360. So that's at 0 degrees, and that is where secant is 1, because that's where cosine is 1. So So those are the only two possibilities. You can't spin around again because you will end up with something that is 360 is what you'll end up with, and that is not in the range that we're supposed to use. All right, we're going to evaluate these functions at these different values. So 19 pi over 6, if you've got 19 over 6, you can reduce that to 3 1/6. So if this is 19 pi over 6, that's 3 1/6 pi. And what that means is spin around the whole circle, that's 2 pi. Another pi is halfway around the circle. And then another pi over 6 is another 30 degrees, which puts you here. And we know that tangent at 30 degrees is opposite over adjacent, so it's 1/2 over square root of 3 over 2. So we're going to have 1/2 over square root of 3 over 2. That's y over x. We're going to square this, and it's positive because these are both negative in the third quadrant. It would have been positive anyway because we're squaring it, so it's not that big a deal in this situation, but you still have to know where you are. All right, then we're looking at cosecant squared pi over 2. Pi over 2 is 90 degrees straight up, and this is the point 0, 1. All right, so cosecant is 1 over sine, so 1 over the y coordinate, so 1 over 1 is 1, so this is 1 squared. And then secant squared 3 pi. 3 pi means you spin all the way around the circle one time, and then one more, which puts you here, and that is the point -1, 0. Secant is 1 over cosine, so it is 1 over the x coordinate, so it's -1, and we are going to square it. So if I work all this stuff out, this turns out to be 1/3. When you square it, the 2's cancel, and you've got 1 over square root of 3, so if you square that, you get 1/3. And then this is -1 plus 1, so it's just 1/3 because these cancel. So that's your final answer for that problem. All right, here we have f of x is secant squared x, and g of x is cotangent squared x. So we're going to find f of -3 pi over 4 and g of 7 pi over 6. So f of -3 pi over 4 is secant squared -3 pi over 4. And then we're subtracting g of 7 pi over 6. So that is cotangent squared 7 pi over 6. Okay, so if we're looking at secant -3 pi over 4, here you are, starting at 0. You're going all the way over here to the third quadrant, a 45-degree angle. That is pi over 4, 2 pi over 4, 3 pi over 4, right here. Okay, so I'm looking at secant. So secant is 1 over cosine, and cosine of 45 is negative square root of 2 over 2 in this quadrant. So negative square root of 2 over 2, but if I take the reciprocal of that, because I'm looking at secant, that is just going to be the square root of 2, negative square root of 2 squared. All right, because the reciprocal of square root of 2 over 2, just so you're with me, if you take the reciprocal of that, you get 2 over square root of 2. And then if you rationalize it by multiplying the top and the bottom by the square root of 2, you get 2 square root of 2 over 2. 2's cancel, and you just get negative square root of 2. So that secant is reciprocal of cosine. All right, then you've got cotangent squared of 7 pi over 6. 7 pi over 6 is, if you reduce 7/6, you get 1 1/6. So we're talking about going 1 pi, which is halfway around the circle, and then another pi over 6, which is 30 degrees. So this is cotangent, so it's going to be x over y now, so it's going to be x is square root of 3 over 2 here, negative square root of 3 over 2, actually, and sine is negative 1/2, so negative 1/2, and then we're going to square it. All right, so if we work all this out, this becomes just 2, and then this is square root of 3, so if you square it, it becomes 3, so negative 1 is your final answer on that problem. So that is lesson 54, the trig functions in lesson 54, and that's the end of that video.